Welcome to Snaps Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about recommendation system for marketplace platform. This topic is based on a tech blog with the title Multimodal Learning for Employment Marketplace Recommendation, written by the data scientist team from ZipRecruiter. You can find the link to this blog in the episode's description. Throughout this episode, I will dissect the topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. ZipRecruiter is an online employment marketplace that connects millions of job seekers with companies looking to hire. From the perspective of job seekers, this platform allows them to search for and apply to a wide range of job listings. Additionally, job seekers can upload their resumes and create profiles, making it easier for potential employers to find them. On the other hand, business owners can use ZipRecruiter to post job openings, reach a large pool of candidates, and discover the best available candidates for their open positions. A key feature of this double-sided job marketplace is to make the search as efficient as possible. Imagine a situation where a job seeker is looking for their next best job. If the search returns job listings that not only fit the job seeker's interest very well, but also make it highly likely for the job seekers to be considered and offered a position by the business. This would greatly improve the efficiency of the employment marketplace. Such an improvement would enhance satisfaction and retention among both job seekers and business owners, leading to a sustainable and profitable business. This is why the business has a dedicated recommendation team, which is responsible for actively generating optimal matches between job seekers and job listings using advanced machine learning tools. Developing a recommendation system is a key lever to make this process systematic and scalable. Now that we understand the business problem to solve, let's shift gear and dive into the data science side to see how the system was built out. One main challenge in building such a recommendation system is about its scale. The platform accommodates over 36 million job seekers, each of whom could potentially match with the 12 million job openings. Given this immense scale, suggesting high-quality matches to users requires an efficient and scalable inference mechanism. The system must calculate a meaningful matching score for each pair of job seekers and job entity. A naive implementation, where one machine learning model scans the entire job database at inference time, may not be feasible due to the high inference costs. To address this challenge, the team chose an encoded entity representation for both job seekers and job listings. During inference time, this method requires the simple scalar product calculations instead of complex machine learning model inferences, leading to a more scalable and efficient real-time inference. The key of this above solution lies in mapping each job listing and job seeker into a semantic vector space, where one critical element in generating such customized embeddings is the so-called encoder module. So what is an encoder module? In deep learning, an encoder is a neural network type that processes input data to create a more abstract and often lower dimensional representation. This concept is prevalent in various deep learning architectures. Considering this encoder architecture, there are two major aspects of it. The first aspects involve the detailed encoder structure, which includes the input data, the layer design, and the activation functions. For instance, the simplest encoder structure could be a single layer feed-forward neural network. It has one input layer that receives raw data, such as word embeddings for text or raw feature vectors for other data types. Next, there is a dense layer, or called encoding layer, which is a fully connected neural network layer transforming the input into a lower dimensional space. Typically, a nonlinear function like ReLU is used here to introduce nonlinearity. The number of neurons in this layer determines the size of the encoded representation. A fewer neurons leads to more compression. The output, or encoded representation, is the final reduced dimension outputs, capturing the input's essential features. After understanding the detailed encoder structure, the second aspect is identifying the ways to train this model for optimization, ensuring that the encoded representation effectively performs its task. In the context of job seekers and job listings, the interactions and behaviors provide cues about job similarities. Training the simple encoder model with contrastive loss involves setting up a task with the pairs of inputs, positive pairs and negative pairs. The goal is to train the encoder to bring representations of positive pairs closer and push those of negative pairs apart. Considering the jobs a job seeker has applied to. If the job seeker applied to two consecutive jobs in the same time, it is easier to infer that these two jobs are very similar from this specific job seeker's perspective. This similarity concept is crucial for learning an appropriate job representation, where similar jobs are closer in this representation and dissimilar ones are distant. With these two parts of the encoder in mind, one focusing on the structure and the other focused on defining the loss function, the team can train the model for the job listing encoder. A similar approach can be applied to the resume side, where the feedback from business owners on the suitability of the resume for a job provides positive and negative signals for training the resume encoder. This leads to embedding representations that can measure the within-item similarities for both the job posting and resumes. Now we know what is an encoder and the above-mentioned two encoders for job listing and resume. Let's see how this is used to build out the overall recommendation system. Each job listing typically contains only static information, such as the hiring location, required skills, and the job responsibilities. These details are stored in a very static fashion. Usually, a company posts a job listing, and all the text involved in it is sufficient to present the representation. So with the above-mentioned job listing encoder, it offers a reasonable representation of the listing in a numeric fashion. However, the situation is a bit different for job seekers. On one hand, each job seeker has an associated resume, which includes static text information like their work history and skills. This can be suitable to be represented with the above-mentioned encoding. On the other hand, job seekers engage in more dynamic activities, such as entering the search queries and interacting with those job listings they have ever saw. These actions are crucial for determining the most appropriate job recommendations and have to be considered into the recommendation system. Let's take one example. There are two new graduates from the same economic departments in the same college. It's very likely they have the exact same resume as their background, but their interest could be totally different. One might have a strong preference to go to the finance industry, while the other one want to join the tech industry. If a recommendation system doesn't leverage the dynamic information about how this job seeker interact with jobs, then its effectiveness could be very limited. With this above consideration, the team implemented additional modeling structures to integrate the job seeker's past activity data with their resumes and search queries. This integration results in a unified, single job seeker embedding that can effectively model the cross-entity semantic relationship between job seekers and job listings. Now we discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we've taken a closer look at how ZipRecruiter designs and builds its recommendation system for their job marketplace. They've leveraged the encoder architecture to effectively model job listings and job seekers' information. Constructing their respective embedding representation, this approach enables them to facilitate a scalable and real-time recommendation system. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.